Hello, Tom from Every Step Calculus, everystepphysics.com. Your friendly, real teacher of calculus. This is a Hessian problem, which I saw. I had programmed it years ago, and then I had found it again, so I was go to the online and get a couple of problems or whatever I do, and then make another video of it. But supposedly extremely important thing you're supposed to learn in calculus. I don't think so. But nice to pass a test, nice to have this stuff in your calculator and have it for the rest of your life if you want to buy my programs. Otherwise, don't, and struggle with it for the rest of your life, whatever. But when you become an engineer and somebody asks you about some of this stuff, you'll be able to do it, even though you'll never do one calculus problem in an engineering, not one. 30 years I've been in this business, I haven't found one useful problem in calculus, not one. Oh, you can find the area of a parallelepiped, you know, and a half circle of a cone or something like that, you know. But all that stuff in electronics, I've studied electronics too, is all done with other calculations and easily done with all the other calculations. You don't need to do a derivative and integral on every damn thing in life when you figure out something, you know, your checkbook or whatever. And of course, if well, let's do this problem here, okay? Index 8 to get to my menu. I'm already at Hessian Matrix. Otherwise, you'd use this here to scroll down or up to it, but it takes some time to get here on the simulator here. So I thought I'd just put it in here and do it quickly. We're dealing with second partial derivatives, okay, of this. In other words, you take the first function, you do a derivative of it, and then you take that derivative and do a derivative of that. What's a second derivative, okay? No variables given. Use it, and then setting up a Hessian 2x2 matrix. So here's the function here. Now notice that what bugged me about calculus teachers and anybody, physics teachers and everything else, is that they're always, when they're teaching you something, now this is the problem that come on here, they're always trying to trick you, make it kind of cool. Can you figure this out? Can you do this? Can you do that? You know? In this case, they have x squared, right? And then this is x1. So that's x1. Here's x2 and x1, and here's x2, okay? In reality, this is a polynomial, and it should be minus 7x squared minus 5 times x times y minus 4 times y squared. That's really what this is. And why not? That's the way functions are in math. You know, they're not x1 and x2 and that kind of thing. So you getting this on your test, you're going to say, what the heck is that, you know? And then x1, x2 equals minus 2 and 2. So, you know, eventually you can put those in if you wanted to find the actual point of what they're talking about, you know, the xy point. But in this case, they're asking you to find the upper left element of the Hessian. Well, that's easy for you, isn't it? You'd have to study that about 2 weeks to figure that out. Not with my programs. We're going to enter the function here. You have to press alpha first. If you use my function, my entry places for the function, you have to put alpha in first to get the calculator out of the out of the letter mode and into the math mode, okay, to enter these things. So I pressed alpha. We're going to put, so I got to go slow, otherwise it'll mess up. 7 times x squared. Well, wait a second, there's a minus sign in front, so let's go back here with this. Put the here's the minus sign. You can't put, this is an indicator, this is a minus sign, this is a indicator for a minus number. And then we're going to go back here. All right, so then we got minus 5 times x times y, 5 times x times y. And then we got minus 4 times y squared. Hopefully that's right. I always show you which way you entered. You can change it if you made a mistake. Minus 7x squared minus 5xy minus 4y squared. Okay, that's pretty cool. We're going to say yes. Okay. So we take the function and we get the first derivatives. Here they are. With respect to x, it's 14x minus 5y. With respect to y, it's minus 5x minus 8y. Okay. Now we're going to take the f of x, which is minus 4x minus 5y, and find it and do the derivative of that, which is with respect to x minus 14, with respect to y minus 5. And then we're going to do the same thing with the y derivative that we found from the main function. Second derivative is minus 8 minus 5. You can see that here. Constants are the derivatives of this, you know. Derivative of minus 5x is minus 5, right? We can all see that, but you'll mess up in a test or something and get something wrong or whatever, you know. And of course, a month from now, you won't even know what happened here. You have to have something, good notes or something. So here's the matrix, minus 14, minus 5, minus 5, minus 8. Well, lo and behold, here it is down here, minus 14, minus 5, minus 5, minus 8. Well, you got an A in that problem. So anyways, go to my site, buy my programs, and pass calculus. Also, you get my fabulous help. You know, I'm in San Diego, so you have to think about the time frame. I don't know what your time frame is where you live, but you can send me your tests, your quizzes. I love them. That's what I do here. I program tests and quizzes. You don't go to the back of the book into an example and just program everything in the calculus book. That's not, what a waste of time, you know. I only program test problems, you know, that other people might happen to get on their tests or whatever. So, okay. So anyways, and don't forget about my physics programs. They're unbelievably great. Years ago, some guy from Long Island paid me $3,000 for his test for physics, and then I got started on physics and been programming that, you know. And of course, with computers, you know, I had programmed lasers and mirrors, convex mirrors, you know, everything. Electronics, you know, coils, capacitors. Wouldn't you know, the computer crashed and I lost all that stuff. So I could program it again. I can program anything in this calculator, which I'm the only one in the world that does this. So out of 8 billion people, I'm the only one that does this. So you're pretty famous if you buy my programs, you know. Hey, have a good one, and good luck in your classes.